So let's review the basics of what we know. We know that a linear quadratic system is a system or a graph that has a line and also a parabola. So there could be multiple points of intersections. In a linear quadratic system, there could be 2 points of intersection. That line hits the parabola twice. The line could hit the parabola exactly once. That is called a tangent. Tangent. Okay. Different than sine, cos, and tangent. This is a different type of tangent. It means it just hits the parabola or the graph one exact time and it's right there. Or it could miss it completely and not have any solutions at all. We know in this situation, the discriminant when we set these two equal to each other will be positive. This discriminant will be exactly equal to 0, and this discriminant will be less than 0, it will be negative. So let's try one more example where we actually find the point of intersection of the parabola and a line. So it says skeet shooting is a recreational and competitive activity where participants use shotguns to attempt to break clay targets mechanically flung into the air. So here are the clay targets, and this little contraption is going to fling it into the air, and someone's going to try to shoot it down. So the height of the disc, which is this guy, is modeled by the function this. And we know that this is a parabola because the exponent or the degree is 2. Where h of t is the height in meters after t seconds after the disc is released. The path of the bullet is modeled by the function this guy. So this looks like a linear function. We know it's linear because the degree is 1 with the same units. How long will it take the bullet to hit the disc? How high off the ground will the disc be when it's hit? So let's draw a quick sketch of what the heck this is looking like. So I have h at t, so I have my height, and I have my time. All right, so we know that the disk is a parabola that opens down, and this makes sense. It's going to get shot in the air and it's going to come back down. So there's the disk. And the bullet is a linear equation with a positive slope. So the bullet is going to look something like this. Boom. There we go. So some sort of linear graph. Now, there should be 2 points of intersection. They might both be positive. One of them might be negative, one of them might be positive. The question it says is how long will it take the bullet to hit the disc? So if our graph is correct, it should hit it right here. So let's take a look at the math and then we'll check if our graph is correct. So we have these 2 equations, and if we want to see when they're equal to each other, all we have to do is set them equal to each other. So that's what we're going to do. We're going to take our disk equation, so our quadratic, and set it equal to our linear equation and solve it. So I'm going to bring everything to the right side. So I have 0 is equal to 5t squared, and then I have negative 32t plus 31.5t, and then I have minus 2 plus 1. So my final equation is 5t squared minus 0.5t. Negative 2 plus 1 is negative 1. All right, so we want to check the solutions to this guy. So not the number of solutions. This question says exactly how long will it take for the bullet to hit the disc. So I want the actual t value. So I don't want to factor this guy because there's a decimal in it. So I'm going to use the quadratic formula. So x is equal to negative 0.5. So negative b plus or minus the square root of b squared. Negative 0.5 squared minus 4, 5 times negative 1, all over 2a, 2 times 5. So if x is equal to 0.5 plus or minus the square root of 20.25 divided by 10. So our two x values are going to be, x1 and x2 are going to equal 0.5 and negative 0.4. 0.4. Now let's take a look back at our graph. In my graph, I have 2 solutions that are positive, and that's what I have here. So this bullet probably doesn't look like this. It must have 2 intersection points, but 1 intersection point is out here. So I'm going to redraw this just so that it matches. So I'm going to take these guys away, and I'm going to redraw this parabola and redraw this line. So if I draw this parabola, I'm going to put the parabola back oop, that's not good. Draw the parabola exactly how it was. Okay. And then our line probably looks something more like this, where it has one positive solution, and if we were to continue this parabola over here, there would be the second solution. So we have a positive solution and we have a negative solution. So clearly we can throw this negative solution out. It's extraneous. It happens in negative time. So we're not going to use this guy, but we are going to use this guy. So this is the time. So it's after 0.5 seconds. Wow, that's quick. This is the time where the bullet actually hits the clay disc. And it says, how high off the ground will the disc be when it's hit? So we got to find this height. So we're going to plug in this 0.5. And the question is, which equation are we going to plug it into? Are we going to plug it into the line? Or are we going to plug it into the parabola? Take a look at it carefully. I want to figure out what this height is, or what this y value is. Well, doesn't this point exist on both the parabola and the line? Yes. So if I want to find the y value, I could plug the 0.5 into the line, or I could plug it into the parabola. I'm always going to go with the line because the line is going to be so much easier to plug into. So I'm going to plug in the 0.5 into our line. So we have our bullet. Our bullet is b at t. So I'm going to plug in 0.5 into b at t. b at 0.5 is 31.5, 0.5 plus 1. And we get 16.75. So that is the height, 16.75. Here it is, 16.75, that the clay, that the bullet actually hits that clay disc.